Hello, and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of rate of change. This is standard A.3B in the great state of Texas, and we are using item number 1 of the 2016 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a savings account, and it looks like we started with some balance of 50, right? So we've got a y-intercept of 50, and then it's growing, but it's a linear function there, so we have a constant rate of change, and that's what we're looking for. We're looking for the rate of change of the balance with respect to the number of deposits. All right, so the balance with respect to, that lets us know we're dealing with a ratio. So balance per number of deposits. All right, so how does that show up on this graph? Well, the balance is the y, and the number of deposits is the x. And when we're dealing with this per, that means that we are going to be looking for the change in y over the change in x. So our deposits are x, balance is y. Hopefully this looks familiar. Change in y over the change in x. Another way to think of it would be rise over run. If you're thinking slope, you are correct. So what we need to do is we need to think of what is the slope of this linear function. That's what this is asking for. So this rate of change is simply asking us for the slope. Well, we know how to find that. We take two y coordinates, subtract them, that's our numerator. Take two x coordinates that are paired up with y coordinates, subtract them, that's our denominator. Make a fraction. So we can pick any points we want to, right? So that's going to be, let's start with that y-intercept 0, 50. And let's do this next one. That's going to be a 1, 150, just because that's going to give you a nice, look at that, it's going to give you a nice denominator. But I'm going to show you that you can do any set you want to, right? So let's label these. Let's make this x sub 2, y sub 2 on the top, x sub 1, y sub 1 on the bottom. All right, so my y2 is 150. My y1 is 50. And then I've got 1 minus 0, my x2 minus x1. So look, 150 minus 50 is 100 over 1, so that just makes 100. So it literally looks like it's just $100 each. But you know what? I said you could do any set. So I want to do this one right here. So that's 450, and let's do that one. So that's going to be 250. And you know what? I'm going to make this my x sub 2, and that's going to be my y sub 2, x sub 1, y sub 1. I want to show you that it really doesn't matter. So my y sub 2 is 250, y sub 1 is 450. That's going to get me negative, but it's fine because look what I have on my denominator, 2 minus 4, also negative. So my two negatives are going to end up making a positive. That's why it really doesn't matter. So 250 minus 450 is going to be minus 200. 2 minus 4 is minus 2. So my two negatives end up making a positive. That's why it doesn't matter what your x sub 1 and your x sub 2 or vice versa. And then 200 over 2, once again, it's going to be 100. And since these are spaced 1 apart, right, you could have just looked up and said, you know what, how high is this going? Right, from 250 to 350 plus 100, and that's just over 1. So you could have just visually looked at that and said, you know what, it's 100 over 1 each time. Going up 100 over 1, 100 over 1. So my answer here is A.